So we're just going to continue with array lists for this session to start with. So we did cover that last week, but there's more to it than we covered last week. So in our test class here, I've added a few comments, a few Java doc things, and there's a few methods we need to know for the exam. We did actually cover these last week, those ones, but we didn't cover the rest. So I'll go through this same class again. I'll just whiz through the bits that we did last week. So if you don't understand those, please, obviously they're on the video from last week. But when we get to the bits that we didn't cover last week, obviously I'll take it a bit more detail in that. So yeah, ArrayList obviously is one of the Java collections classes, and it maintains its own array and then presents various methods to you to manipulate that array. So it's basically just a more sophisticated way of maintaining an array. So we showed last week that you can create an array list like this using a constructor. These three examples here don't type the array list, so you could put any object in there. You could put strings in there, animal classes, system classes, whatever you wanted would be accepted in there because you're not strictly typing them. These ones are strictly typed, so we're saying here using these angle brackets with string inside, once you've created this list, you can only put strings in it, and you'll get a compiler error if you try to put anything else in it. That is actually the better pattern, really, because when you're then getting things out of the array and manipulating them, you know you've got strings here. But these could have anything in them, so you have to be really careful when you get things out what you do with them. Then what we did, we created some animals, some instances of the class animal, and we constructed a list typed with animal, and we started adding those animals into it. So the first couple of methods we look, and they're numbered. They're numbered in the class to correspond with the numbers up here. So the first couple of methods we looked at was add. So adding, simply adding an object, and if we add it like that, they just go to the bottom of the list. Or we can add it at a specific place in the index. So we covered that last week. And what I've also done, another thing we did last week, we implemented a logger. So I've got logger statements in here rather than the system outs I had before. So if I run that as it is now, there's all these logger statements, and nothing gets printed, and that's because in the log for j.properties I've set the threshold at info. So anything lower than info, i.e. debug, won't get printed. Another thing I've done is I've changed the pattern here, so it's really simple in our console appender, so that's going to be appending to here. I've also got a file appender, and that has a more complex pattern there. We'll see that at the end. I'll look at the log file, but basically that's because I just want these logs to the console for our purposes in this and these classes to be as simple as possible. So that's basically going to behave just like system outs do. It doesn't bother with timestamps and all that kind of thing. So I ran this class, and they're all my logger statements in there are debug. So when we want to start running these, we can just change them to info, and they should start printing out for us. So having added a few things to our animal list, we can then print it. And of course I've got to do it there as well. So having added to the animal list, there we go. There's the contents of that animal list having added to it. Same with remove. We removed the tiger there, so it's going to go through that again, and the tiger's been removed. We only got two things in there. We add it back in again there, and then I'll do these too because we did this last week. Then what we do, we remove something, but we remove it in a specific index 1. So we're saying rather than removing an actual object, we're removing something at index 1. So, and then we get the output there. We've removed Tammy Tiger because Tammy Tiger was at index 1. So far we've just whizzed through those 4 again there, which we did last week. So then what we did, we created, we mentioned as well, it's as I said at the start, it's not necessary to type the array list, so this doesn't say animal here in angle brackets, but if you do that you can run into troubles, like here, so there's nothing stopping us just adding a string in there, which kind of makes it a nonsense, because when you then when whoever gets your list says, oh, here's an animal list, let's get all the animals out, and suddenly they're confronted with a string. So that's why it's better to type lists, because the user, the client of your code, knows exactly what's in that list. And then if we tried to, so that here we're getting things out of this list, here and printing them, and we'll get an exception there because it's trying to treat that string that we put in there as an animal. Also, it's forcing us to use explicit casting here because we haven't typed that list. So when we're getting things out of it, we're forced to do that because as far as the JVM is concerned, it doesn't know what's in there. Obviously, if you type it with the angle brackets and animal, you don't have that problem. And obviously, if I take that out, it should work now. Work okay without any exception. But it's always best to type them if possible. So the other thing we covered last week, you can convert using this toArray method. You can convert a list to an array. So there we have our array, our square brackets. So you're taking a list, an array list, you're converting it to an array. And just to prove that, we're going to print the length of the array there, just to show, well, that should have all the elements that list's got in, which I think is 5. Yeah, 5 there. And then we can go the other way. So we've used toArray. Now we're going to use this arrays as list method. So arrays, remember, is a utility class to be used with arrays. So this time we're taking an array and converting it back to a list again. So we're effectively just doing the exact reverse of what we did before. I'll actually call this one animal list from array. So if we print that out, there it all is, animal lists, contents having been converted from list to array and back to list again. There they're all there. So here's one we didn't cover last week. Excuse me, it's set. So this time what we're going to do, we're going to take this list. It's the same one again, animals list from array, so it's this one here. I'm going to set the animal at position 1, which currently is Timmy Tiger, and set it to lion 2. So let's do that. And so what you'll notice is lax lion appears twice now. It doesn't disappear from where it previously was, but we're telling it put the animal at position 1, set it to lax lion. So set doesn't change the size of an array, but it changes objects in the positions that you specify. So if we do the same again now, we change the animal at position 3 to this tiger here, and do that. So now what we've effectively done, we've swapped the positions of lax lion and Timmy Tiger. If we go back 2, we've swapped their positions by using the set method, step by step. There. So set is just to say exactly where you want something in an array, ordering it. So the next one is empty. Again, the names are pretty self-explanatory here. So it's just a boolean. It gives a true or a false. Is this array empty? Yes or no, true or false? Well, we know it isn't. We know it's got 5 things in it, so we expect that to print false. And we'll look at is empty in action in a minute. Yeah, printed false there. Let's get rid of that. Clear is the next one. So what this is going to do, this is going to clear down, take all the elements out of your array list. So it's just dot clear there. So we've cleared that. Now we're going to print out what's in it. So that's info. And there we go. So here's our introductory sentence, and then there's nothing afterwards because they've all gone. We don't get any null pointer exception on it because we still have our list, it's just got nothing in it. So contains method is the next one. Again, it's a true or false. Does this list contain the object you're telling it about? So in readiness, I've prepared this new animal called chimpanzee, basically, Charlie chimpanzee there. But first of all, I'm going to say, does animal list contain lion? It does, because it's one of the ones we put in right at the start. So, does animal list contain lion? We should get a true there. Contains. There we go. Does it contain tiger?
Okay, so I think I've got the wrong.
go. That's just a little bug on my part. I think it contains. I'll tell you what we can do here. We could. Well, it's a different. This one, animal list is. Oh yeah, it's cleared out. So good, well spot, Giles, there, because I think earlier on I was using a different array there. Let's take that out, and well spotted. Yeah, so it's true. So we've taken that clear out. It's true. Well done, Giles. Then we'll check. Well, does it contain Charlie chimpanzee? No info. It doesn't, because we've just created that chimpanzee. Then we haven't done anything with it yet. But then we'll add it and we'll do the test again. So let's do those two. Let's do those. So before it didn't contain it, after it did. So this is the next one is equals method. And remember, that's one of those special methods that's inherited from the object class. So if the writer of ArrayList didn't override that equals method, then it would just behave the same way as the equals operator. So what we've got here, we've got two lists, animal list 1, animal list 2, both contain exactly the same animals in the same order. So let's just see now. We're going to see, well, both lists contain the same elements, and your testing equals method here. Is it going to give a true or a false? I would hope a true, because they contain exactly the same things. Yeah, true. But a bit of revision here, we keep coming back to this, the difference between the equals method and the equality operator, this thing, equals equals. Because here we're saying, are they not only meaningfully equivalent, but are they literally the same object? Well, they're not the same object, because we created them both using the new operator like that, the new keyword. So that's going to be a separate object with a separate object reference on the heap. That's going to be a separate object with a separate object on the heap. So even though they're meaningfully the same, they don't equal each other. They haven't got the same object reference. So that's going to be false. Yeah. And then now what we do, we add a line to the second list, and we do the same test again, and this time we expect that not only is the equality operator going to be return false, but this is going to return false as well, equals method, because they no longer contain the same elements. So expecting a couple of falsies there. So that's right. The next one is size. Well, that's a fairly obvious one. In fact, I think we've come across it before. We just want to know the size of a particular list. So that's one that we created from the array there. Let's just see what the size of it is. Oh, right, that's not going to print because I need to change that to info. Oops. Info like that, there we go. And just run that again. And the size is 5. And that tallies with, if you remember when we did it up here, when we tested the name of the array we created, it was also 5, so it makes sense. It's got all the same, same size. So size is the next one. Then we talked about the fact that, and this leads this is going to lead us into wrapper classes again. But before we do that, I just wanted to just show you this size and the isEmpty methods kind of in action. Because if you remember, we've got the zoo class somewhere. Zoo.java there, and it prints an inventory of all the animals in the zoo here. So, and we put a guard condition in. We did this in the session last week. We said, well, if the animals list that this zoo contains is not null and is not empty. Remember, this exclamation mark is a negation operator. It's saying not empty. So then print out all the animals in the list. So that's the isEmpty method, which we just covered. And another alternative to that, you could exactly has exactly the same effect, is to check is the size greater than 0. It's kind of like the same. Size greater than 0 is the same as asking is it empty or not. So you can use either of those there. Just showing the usage of those methods in practice. So to go back to this again, so those are all. So the methods at the top that are listed, they're pretty much covered there, and as is this one, the asList method from the arrays class. There was one other we covered last week. It's the sort method from the collections class. So just to remind you that arrays is a utility class which has methods in it that you can use with arrays. So we've used binary search, sort, and here as list. Collections is a very similar thing for collections classes, and collections classes are things like ArrayList we're using here, hash map, all those kind of things. A set of utility methods you can use with those, and like sort is one of them. So right at the bottom here, we've put a list of integers together and put numbers in them not in numerical order. We then call that collections.sort on that number, and it prints them. Done that again. It prints them actually in order because you've sorted them. You've sorted them using that. So just show that one there. Sorted numbers using collection sort 58199. They're in order. So just to talk about wrapper classes again. To go back up again, we just touched on it last week. You can't create, so lists can only contain objects, they can't contain primitives. So when we tried to do that, it fails compilation. You see the little red squiggly lines there. You can't have a list of primitives, they must contain objects. And then we said, well, it looks here, we created a new list here called numbers. It looks like we are adding primitives. It looks like that is a primitive integer. So what's going on behind the scenes? And we explained last week that actually what happens behind the scenes is that for every primitive type there is an equivalent wrapper class. So I've just got a website here that's just got all these wrapper classes listed here, so that's a bit in the way there, but you can see that here are our primitive types, the 8 that we're familiar with. They all have a corresponding wrapper class. So those are classes that literally just hold one of those primitive types and then expose methods to it so that you can interact with it, an object equivalent to a wrapper class. And Java, the JVM, employs this tool called autoboxing. And what that means is that you can kind of use the two interchangeably. So what it's kind of trying to be kind to the developer. It's trying to say that, okay, although we can only add objects to lists, I know what you're trying to do here. I know you're trying to add, you're trying to add 3 the int, and you can't do that, but you can add it as an integer. So what I'll do behind the scenes, I'll auto box that. I'll put that 3 in its box, in its wrapper class, automatically auto boxing, and do it for you behind the scenes. And to the developer, it can seem seamless. Just to prove, like here we've got another integer 3. This time it is actually an integer as opposed to an int. This is an actual wrapper class, and we can quite happily add that to the object too. And here we're adding another one, and this is an anonymous object here because we're not naming it up front. We're just saying chuck this new integer into our list. I'm not going to bother naming it. So you can interchangeably, you can add what look like primitive ints and actual integer objects, and behind the scenes it'll auto box the primitive ints into the appropriate wrapper class. So that was like an introduction to wrapper classes. So now to just take that a bit further, we've got a wrapper class tester. Well, I've got this one called integer tester. Again, we've got some Java doc at the top, and we're going to use, so there's 8 of them because there's 8 primitive classes, these wrapper classes, and we'll use integer to demonstrate it, as we already have just now in the ArrayList tester. But the principle here is the same for all those different wrapper classes. So where you have a method called parseInt here for the integer class, for the long class you'd have parseLong or parseByte, parseByte for this, and parsefloat, etc. They all have equivalent methods there. So a couple of things to say before we start off. Why do we bother having wrapper classes? Because isn't it defeating the whole object of just having primitives? Because the idea of having primitives is you save memory on the heap. You don't have to create an object, which is true, and we use primitives wherever possible. But there's a couple of reasons why you might want to use, you might be forced to use a wrapper class. Well, one thing is just going back to the whole origins of object-oriented programming, because many of the more strictly object-oriented languages don't have primitive types at all. Everything has to be an object. Absolutely everything has to be an object. Java came along and introduced primitives, and it got criticised by some object-oriented purists by saying, oh well, it's not strictly object-oriented if you've got all these primitives in there. So by introducing these wrapper classes, you can be completely object-oriented if you want to, and not even bother with primitives. So that's there for the sort of purist form of object orientation. Another reason, really practical reason, is that certain methods won't accept primitives. You have to put an object in, and we've just dealt with one. We've just dealt with ArrayList. ArrayList won't accept primitives. You have to pass an object in there. And you might think, well, why don't they accept primitives? Well, here's just one theoretical example. Say, for example, you had a class of 5 children. They're doing a maths test, and you want to record their scores from 0 to 5, depending on how they score. And you put the integers in that list ready, just ready, like with no value yet. So they all start off, if they were primitives, with their default value, which is 0. If you remember, all primitives have a default value, which is 0. So you have all these 5 zeros in the list, and as these children take their tests, you update those scores. So maybe, let's say 3 children get 5, 1 child gets 0, and the other child doesn't turn up at all. The problem with that is that there's no way of differentiating between the child who actually got 0 and the one who didn't turn up at all. So it can skew your results. But if you used objects, the integer objects, the default value of an object is null. So what you'd have if you started your list with the 5 students, you'd start off with 5 null objects. When the children finish their tests, you start to get an actual integer value. So for the 3 children who got 5, there would be an integer of 5 there. For the child who scored 0, there would be an integer there with a value of 0. But for the child who didn't turn up at all, there'd be a null object. So you can differentiate between 0 and null with objects, with an integer object. You can't differentiate between an actual score of 0 and just a default int, which gets assigned the value 0. So it's a roundabout way of saying that it's safer to use these integer objects. You can differentiate between a genuine non-show, a null, and a 0. So that's obviously one reason for using them. What we've got here, by the way, we've got the number 5, but we've got it kind of modelled in 3 different ways. We've got 5 as a string, with literally as 5 in quotes there. We've got int 5 as int, which we'll assign in a minute. And we've got 5 as wrapper, so it's integer class. So 3 different types. We've got string, integer, and int, and they're all going to have the value 5 in their own different ways. So the string is obvious, we do it this way. What we're doing with 5 is int. And here is a method we need to know. It's parseInt. So integer can be used as a utility class to just pass a string in there and get the int value out. So we're assigning this to. It's going to take this as a string and convert it to an int. So parseInt, and you can tell that that's a static method because you're using it direct on the class name. You don't have to do a new, integer, my integer equals new integer. You don't have to do that up front. It's just a static method, so you can call it directly on the class name. And then so what we end up with here is 3 different versions of the number 5. We've got one as a string, one as an integer, which has been parsed from that string, and one as an actual wrapper. So if we run that class, that's integer tester, I think it's called. Yeah, integer tester, and run that class now. It should they're effectively they're all the same, but we know they've had different roots, as it were. Now, if you change that to something like that, you get a number format exception, because this method parseInt has come along. It's tried to turn that into a number, but it can't. That's not possible to turn that into a number with a letter G in there. So that's where you have to be guarded using that method. You have to make sure that you meaningfully pass it something, or you'll end up with a runtime exception here, a number format exception, which is a type of runtime exception. So 5 as wrapper, here it is. We've called it a new integer, 5. You can also there's also this thing, value of. So in integer, this is another utility method. You're passing it in a string, and you're saying, give me the value of that string as an integer object. So parseInt returns a primitive int, value of produces an integer object. But they just utility methods of taking strings and returning them as actual ints or integers, respectively. So again, 5. These are always, so it gets a bit boring. I've used 5 in all these examples. So what you can do, you can also do this parseInt. You can get something from your array, your args array, the one that you pass in at runtime if you want to. So let's do that. So what I'm saying is, get me my runtime arguments that I pass in when I'm running the program, and convert the one at position 1 into an int. So run that again from there, and it gives the number 2, and that's because I've put, if I go to my where is it? Edit configurations. I've put it in there as the second argument. Remember, I referenced it as 1, but they start at 0, so that's 0, that's 1. If I actually do that, we'll end up with that same exception again, because that's you can't convert the number to. It has to be something. There we go, number format exception. And if I do that, I'll get another error, index array index out of bounds exception, because there isn't an element in our args array with position 1. There aren't any at all. So we have to make sure that, again, what we pass in is meaningful. So let's do that. That works fine. So that's obviously 2 in there. That works. That's working fine. Right. So now this idea of autoboxing. So where you can take an integer and behind the scenes, so int and integer, they're kind of interchangeable, because behind the scenes, if a method actually requires the wrapper class, it auto boxes the primitive for you. So to demonstrate this, I created these 2 methods at the bottom here. They do all they do is that they print the value of what you pass them. One of them takes an int, and one of them takes an integer, but they print exactly the same, and they've just got, you can tell the difference because one of them is saying primitive, one of them is saying integer. And all this section is doing here, it's calling those methods, but one of them you're passing in a primitive, and one of them you're passing in a wrapper, a primitive wrapper. So you're calling both of these methods. First time you're calling it with the type it actually wants, and the second time you're calling it with the other type. And if we hadn't had these sessions and explained it, and you were new to this, you'd think that 2 of those would be incompatible, because you're calling the same method with different types here, but actually they're all absolutely fine, because auto boxing works behind the scenes. So if you pass a wrapper and it's expecting the primitive, it'll take that out and use the primitive. If you're passing a primitive and it's expecting a wrapper, it'll auto box it for you. So this works actually fine in all cases. So put that back in there again, and they work fine. There's some more printouts here because these methods get called again later on, but it's just hammering in the point that you can kind of use ints and integers interchangeably behind the scenes. So that was calling those methods there, just to show you that show auto boxing in action. So 5 is int, and again you can show here that this is an int and this is an integer, and I'm actually assigning one to the other, and here in reverse. So again, it's just showing auto boxing and working. This is an int and this is an integer, but you can assign them to each other. So again, that would look impossible. It looks, from what we've learned in previous sessions, but it works fine because these are interchangeable. What happens now? This of course doesn't work. So 5 is int, that is actually an int, and that is actually a string. So you can't do it that way round, because 5 as int is an int, and 5 as string is a string. So you can't assign those to each other because they are genuinely incompatible types. But these two, integer 5 is wrapper and int 5 is int, they work fine. You can assign one to the other. It's completely seamless. So yeah, another thing to say. So here we've already done this. We've said integer the value of method. We've said you can take a string as long as it's a genuine number in that string, and it is in our case it's 5. You can assign it to our wrapper class, but exactly the same thing here. This is exactly the same code there. You can assign it to a primitive int as well, and it doesn't complain because it's doing auto boxing behind the scenes. Another thing so 5 is integer. We can get 5 as wrapper dot int value. Now, if we didn't have auto boxing, we'd have to be doing this all the time. We have to say, okay, this is an int and this is an integer. Therefore, to assign the value that's in the wrapper to the integer, well, let's get the int value out of it. But the thing is, we don't actually need it. We can use it, but even if we do that, it's the same because it does it for you. But this is what autoboxing is. Autoboxing is calling that method implicitly for you behind the scenes, so you don't have to bother doing it. So that's redundant. I've said it's rarely necessary to do that. Again, there's some more examples of calling those two methods there to show that principle. That's why we've got these extra printouts here. So we've done all this with these examples. Excuse me, using integer, but just to show another one, we've got double. Let's use double. So there's the primitive double D equals double the wrapper class, parse double, and then we pass in a string. That's a string there, exactly the same as we did for int before, and we just print that out. Excuse me. So just to show that it's the same principle as integer, but we've used integer, but exactly the same principles apply to all those 8 wrapper classes. And yeah, it's just saying here autoboxing can be used when constructing a list. Well, we've already seen that in our ArrayList tester. We're saying that this is a list of type integers, and we appear to be adding primitives in there. It's exactly like we did in this class here. Behind the scenes, autoboxing is in operation there. And when we print that, it shows us our array list has got 1 and 2 in it. We're printing that out here just to show what was in that. Sorry. So another. So here we've got this remove method. So here we get again. This is a revision from our array list tester. If we remove, this is the thing to take care with autoboxing here, because we're saying here numbers remove 1, so you might expect that it would remove this, but actually this is the index 1. So the index 1 is 0 and this is 1, so it's going to actually remove the number 2. So if we print that, so that's where you have to kind of be careful. So you kind of intuitively looking at it think it's going to remove that, but it removes that because it's doing it by index. But if we comment that out and do this instead, so this time we're actually passing an actual integer in with the value of 1. So you're saying remove that from the list. So it uses the equals method of the integer class, and it says, well, is there something in that list that meaningfully equals that? There is. It's this one, and it removes that one. So this time we'll get the first one removed. And 2 will still be in there. I just need to change that to info so that it gets printed. So it's the opposite situation from before. 2 is still in there, and then of course if we actually comment both of them out, put both of them back in, then obviously both of those things are going to get removed, and we'll end up with an empty. There we go. We end up with a completely empty list there. So we covered array lists and wrapper classes. That's all you really need to know on wrapper classes. And most of it, the thing to really take home from it is that most of it's done behind the scenes for you. You rarely have to actually use programmatically convert between one and the other because of this principle of autoboxing, which has kind of been hammered quite a bit in this test class. So to finish off chapter 3, I'm not sure if we'll get through it today because this is like a 200 odd line, you know, test class, but it's datetime, and it's useful, and I always like ones that you see a genuine usage, everyday usage for, and this is definitely one of these because it's all about dates, times, and timestamps and manipulating them, which we obviously use quite a bit. And so again, some Java doc there. There's these 3 classes are the main ones that we're going to be looking at: LocalDate, LocalTime, and LocalDateTime, and they're all part of the java.time package there, so they have to be imported to be used. Java.time package there. But before we do that, it would be almost wrong to not introduce something that's the way we used to do it before Java 8, because we used to use this calendar class. So you won't be tested on calendar class in the Java 8 exam because this is before Java 8, but it's so ubiquitous that you will see it in code all the time. So just be aware that there is a class called calendar, and it'll be a long time before that's deprecated because it's in lots of live Java class code at the moment. But this is how we used to do it before Java 8, and we still can if we want to. Calendar, I call it cal, equals calendar.getInstance. Again, that's a static method. We don't have to create a new instance of the calendar class to get an instance of it, and that's because what you're basically saying is you're saying I want a timestamp right now. So it can do that by sort of reading the system time or whatever. You don't need to create a new calendar object to do that. You can just do it in a static method. Static methods are kind of methods without state in a way. You don't have to be passing things to it and placing dependencies on it for it to be able to work out what the time is. So it's quite happy to do a static method there. So calendar get instance, and to convert it into a date object, we do this calendar object get time, and then we print that like that. So that's the old way of doing things. Just to show you that working, that'll give us a print out there of I think I've got a couple other commented out there. It does, yeah, there we go. I'll put those back to debug for now, so we can just get to those when we get to them logically. Yeah, so run that again, and there we go. The first line there is now from the calendar class, and it just gives us an exact time stamp of where we are right now. Now, before even that, so this is like a history lesson now. Before even that calendar class came about, we used this date class directly. We're still that's the same class that we're using there, but it had its own constructor where you'd pass in the year, month, date, etc. That crossing out, it means it's deprecated, and the IDE, IntelliJ in our case, tells us that's deprecated. So you can still use it. It hasn't been completely removed, but its use is discouraged. It's deprecated, and probably that will eventually go that way too. But that's how you used to do it even before the calendar class came along. But on to the present, Java 8, we've got these 3 new local classes here. They kind of do what the calendar class does, but they make it easier for you. And the use of the word local is a clue of one of the things it does to help you. It works out your own locale and does things in the background to make adjustments for that. Whereas a lot of the things you used to do with calendar class, you had to tell it your locale and that kind of thing. So but anyway, if we just print those for now, we're doing exactly the same thing as we did with the calendar class. And instead, so calendar had this get instance method. These ones, they all have a now method, and again, it's a static method. Static method. You don't have to create a new instance of these classes to get it. So local date, local time, local date time now, and let's just print those to see what they look like. They're all static methods. It cuts down on overhead. If you have a method that you can call without having to create new objects, it's good to do that. And they're obviously static methods. They're owned at the level of the class, because all they're doing is producing a timestamp, so they don't need to have any state. And what's relevant for one instance of the class will be relevant for all of them. What time it is now, it doesn't matter if you've got 1,000 instances that's relevant to all of those. So that's why these methods are kept at a local, at an instance level. Sorry, to a static level. We don't need instances of the class to do that. So here we all are. You'll notice the formatting slightly different from what you've got here. We'll come back to formatting later on, but essentially they're all just printing the set as a timestamp. This one is a date. This is an actual time to nanosecond precision, and this is a date timestamp, which basically puts both of these together with a T in the middle of it there. So those are the three classes we're looking at there. So now is a static method to create a timestamp right this moment, but you can create a time of whenever you want to. So there's a pretty random date here of January the 20th, 2015. By using this of method. Now, again, it's a static method because we're not using any instance of it to create it. We're doing it directly off the class there. And the thing to know about this of method here is there are many overloaded forms of it. Now, overloaded methods are a big part of Chapter 5. But so this is just a nod to what we mean by overloaded methods. What we mean is methods in the same class of the same name, but they take slightly different parameters for convenience sake, for the people who are using them, i.e. us. It's for our convenience. So like I might want to construct a date by telling it what the month is by using this enum of months, or I might want to create a date using the month, giving its number reference there. You've got this overloaded methods that take both of those. Similarly, so just put the info in there. Then do some printouts in a minute. Those. Similarly, for times, you might want to you might only be concerned with hours and minutes, or you might be concerned with seconds, or you might be concerned with nanoseconds. You have this of has overloaded versions that handles all of those those instances for you. Say if you only had one of these of methods. So you only had, now if they were only going to give you one of them, they'd have to give you the one that gives you the most options. They'd have to give you that, because otherwise you'd have no way of doing a nanosecond date. If you only wanted one with minute precision, you'd have to call that and pass nulls in there like that. So it's never a nice thing to do. You'd have to do something like that, and which is not a nice. It's never nice to be passing nulls in there. So just get that to there. So that for convenience and and also passing nulls around is a recipe for inviting null pointer exceptions. So there's these overloaded methods that get around that for you. So that. And finally, we can do it with a date time as well. So we've got this of method of date time, and here I'm passing. So this time we're passing loads of things there. We're passing all the date things and all the minute things in there. So we've got an example of this of method, overloaded method for both the date time and date time. And the concept of overloaded methods I've gone into in much more detail in Chapter 5, but this is just a kind of nod to that direction that we'll be dealing with those. And here is examples of overloaded methods. So if we just print those, we'll see them in action there. So yeah, here's the dates. So they were constructed using an enum there and an integer there, but they both give the same result. The time one we gave different levels of precision, and there's the date time one here that we did there, and that was fine as well. Another thing you can do with date times, because date times basically have a date and a time, you can use the of method, again another overloaded version of the of method, and pass a date and a time in. So you could for a date time you can construct it using a date and a time object. So that's another very convenient thing for us developers, that they give us all these different options of how you create these things. So there's the one that was created using the date and the time together there. So I'm just reading my notes here. It's just saying that they all have different overloaded of methods, which we kind of laboured that point a bit. And these are static methods. They're static methods because we do, if we might as well use static methods where we can, because it cuts down on unnecessary object creation. And what you can't, so in fact, it's quite strict about it. So you simply cannot do that. You can't create an instance of local date. And you can see here why. It has got a constructor, but it's a private constructor. It's a private constructor. So what the class is saying is, I don't want any calling class to be creating instances of me. I'll handle that myself privately. I'll just give them static methods, these of and before we had this now and these various things. It doesn't want developers to be creating instances of it, because that's not how it's designed to do. So here we can show, now they're actually quite intelligent. Now this is the thing that they have over the calendar class, really. Calendar class kind of let you do nonsense things, but or well, it let you do nonsense things, but it also required of you that you yourself mentally had to work out things like, for example, is this a leap year, or how many days are in this month, and you as a developer had to think more about that. But this handles it better for you. So here we see, for example, we're saying the 32nd of January, which obviously doesn't exist. So if we print that info, it will say, invalid value for, it's telling you it's a date time exception. So it's it handles that for you. So I'll take that out. So and other ways in which it's clever, we'll see now, because we'll do some date manipulation now. So we'll start at we've got this thing called start date, which we're creating. Again, it's a fairly random looking date, 20th of January 2014 for some reason, and we'll just, so that's before we're using this of method to create a date, and we'll print it out. We're expecting it to be, that. So just confirm that it is. Yeah, I mean the formatting's not the same, but it is. It's the 20th of the 1st, 2014. So it's what we want it to do. So another thing here, I'll change my notes. There are lots of plus and minus. Right. So we already said there's lots of overloaded versions of that of method to create a date. Now, when you're manipulating dates, there's also a lot of these plus methods available to you. So if I just hover there, plus, and just let the IDE suggest some things to me, you can see there's all sorts of things it's offering me here. Plus weeks, plus months, plus years, plus, and your own temporal amount, which we'll come to in a minute. So it adds these, it gives you all these different plus methods. So here we're saying, take this date and add 2 days to it, basically. And as you'd expect, it's now going to become the 22nd of January 2014, 2 days later. So that works fine. So if you contrast this a little bit to how it used to be done with the calendar class, well, to construct it in the first place is a little bit more rigid. You have to go through an intermediary class, Gregorian calendar, and pass in these things, and then you're having to tell it, you're saying, well, this is a generic add method, it's not plus days or anything, it's generic, so you have to tell it, well, what are you adding? I'm adding the day of the month by two there. So it gives the same result, but it's not quite such a kind looking. So it gives the same result there. It's not such a kind-looking API. It's more wordy, and obviously that's just a very simple manipulation. If you're doing big manipulations and things, it can get a lot more awkward using the calendar class. But say calendar's not on the syllabus, but it's always worth just referencing it there, just knowing being aware of it, because it's fairly ubiquitous. So an example, just adding a week now. So 22nd of January, adding a week is going to be the 29th of January. So print that out. And so it is. So yeah. So what are we going to do here? We're going to add a month to that. So if you add a month to that, now this is where it's a little bit clever, because February, unless it's a leap year, doesn't have a 29th. So if you add a plus month to that start date, it's it works it out for you. It says, okay, 2014 wasn't a leap year, so adding a month to it is 28th of February. just an example there. You can add years as well if you want to, plus years. It puts it up to 2019 there. So this time let's look at an actual leap year. So I've got this thing called leap date. So 2016 was a leap year. So we'll be constructing it 31st of March. So first of all, let's just print that out. 31st of March 2016. There it is. So that's what we expect. So minus months. So again, minus months, it would be the 31st of February, which doesn't exist. So what it does, if you take a month away from it, it knows that 2016 was a leap year, so it tells you it's the 29th there. So it does that. Now, if you add a month to it again, now, if you add a month, it doesn't then go. It'll go and say, well, was there a 29th of March that year? Yes, there was. So 28th of March. So if you add a month, it'll go to the same day if that day existed. It only does these manipulations around leap years and months with different types, days in them. So it's intuitive. It does what it thinks intuitively you're trying to do. So I'm adding a day to that leap date now. So we get the 30th of March, and then minus a month. So again, it wasn't the 30th of February, so it's going to go back to the 29th of February again. So there it is there. It's just again, there's lots of these plus and minus methods. We've been using like weeks, months, days, years. You can also do them with the time class. They have them for minutes, hours, and seconds, and nanoseconds as well. Yeah, and we've already said we can construct a date-time object by putting in a date and a time object in separately using that of method, which is what we've done there. And we print that out. And again, this was all using the local date class. The ones we've just done was all local date, but you can do very similar manipulations with the local date time class. So what I'll do, because it's similar to what we were doing before, I'll just do them all as one block. But you can see we're minusing days, minusing hours, minusing seconds, and we're creating it there, and then we're adding the various things, and hopefully the results there are what we expect. So we're starting here at 5:15 a.m. on 20th of January 2020. Take a day off, yeah. So we go back to the 19th. We take 10 hours off, so we go back to the previous day at 7:15 in the evening, and we take 30 seconds off. And it's it does what we predict. So it another thing that calendar class wasn't very good at was like overspilling onto the next day or going back to the previous day. The developer had to do a bit more of the clever stuff, but this does it for us. It's very good at like spilling over to the next day. It knows what to do, in other words. So yeah, and just to say as well that you can chain. You can all those methods, these plus and minus methods, they can be chained together. So we talked about method chaining before. I think we did it with the string or string builder classes, where you can add those methods one after another. So what this does, this is a chained date timestamp. So it starts off by creating it based on a date and a time, which you've created here, and then you can just chain these manipulations together like that. And so just have a look at that one, and I think it gives us pretty much the same result as here, or very similar anyway. Yeah, the same result as before, but that's chaining all those methods in one rather than doing about four or five separate method calls. So dates, like strings, are immutable. So what you have to remember is that, you remember with a string, if you did a manipulation on a string and didn't reassign it back to an object again, you would lose that manipulation. So here we've got 20th of January again, 2020, and we're doing plus days to it. So you would expect that to go to the 30th of January, but because we haven't reassigned it, that gets lost in the same way as it does when we don't reassign a string operation. So what you have to do there is you just to correct that, you'd simply do reassign it back to itself again like that. Otherwise, it's the same with strings. You get a new object created, but your variable reference is still pointing to the old object. So when you do date 7 plus days, you still have the original data object, which represents 20th of January. You now have a new one representing the 30th of January, but your variable reference is still pointing to the old one again, and the new one effectively is useless. It gets lost immediately. So you have to do, you have to do this reassignment here, and that works. And now you've got the 30th of January as expected. Another thing to do is, so here we've got our local date. What you can't do, you can't use the plus methods that are inappropriate to the type. So a date doesn't have minutes in it. That's for times. So that it simply doesn't compile if you try to. So plus minutes is a valid method on a local time, but it's not a valid method on a local date. So you can't do that. And that's, again, you wouldn't expect to be able to. So you can use dates in conditionals and loops here. So we've got a start date and an end date. They are basically 1st of January is the start date and the 30th of March is the end date. And we're going to just iterate through those. And we'll introduce a new method here as well, because this is another very handy method. There's a method on these local date classes, is before. So you can take one date and say, is this before this date? So again, it's a bit easier. It's a nicer method to use than we used to use on the calendar class. So at the start of this, this date is before this one, because January is before March, obviously. And then, but then what we do in each passing of the loop, we're going to plus a month to the start date, and then we've got a while condition. If you remember while clauses. While loops, it's only going to keep doing this loop while start date is before the end date. So as soon as it's not, we'll get out here and we'll have a printout that it's now gone after that. So just do that, just to show you can use dates in loops, and you can manipulate them in a loop like that. Yes, where are we? Yeah, so yeah, that one needs to be sent to info as well, like that. There we go. Because our logger is, of course, at info level. So there we go. So you can see that it passes through 3 times when it's before, and this is getting incremented each time. And suddenly it's now after. So that's usage of that's the is before method there. So another thing we can do is we can use this thing called period. There's a class called period here, and we had all those plus methods, but if you remember, we had plus and minus months, plus years, plus dates, and there's lots of plus and minus methods. There's also a method that's just plus, and you pass into it, so it's plus and it's just plus in brackets, and what you pass into it is a period, an instance of a period class here. So when you have the method like plus days and plus seconds, etc., the element of the timestamp that you're manipulating is baked into the method itself. So plus days is obviously going to change the days, plus seconds is obviously going to change the seconds. But when you use the generic plus method there, you're passing the responsibility of which part of the date you're changing to this period method, this period class. So here we're saying, well, I want to introduce a period of a month. I'm going to so this period class represents a single month. And again, we've got the period class has an of months, or it has of, if we look at that, it has all the usual things of months, weeks, years. So you're delegating the responsibility of which element to that class. And this time we're going to call the plus method, whereas here we were doing plus months. We're going to do plus method and pass this period in. And it's going to be exactly the same, because in this one we were incrementing by 1 month at a time. We were doing plus months 1. This time we're passing in this period object, which itself represents 1 month. So this should behave exactly the same as the other way around. And get to the end here. and it does. So it behaves exactly the same as before. So that is the period class. So that is used at the level of the date. So you can have months, weeks. Let's have a look. What did it have there? Months, weeks, years, days. The similar. There is also a class called duration, and that one is the same as period, but this does it of the time. So it's hours, milliseconds, seconds, nanos. So period is like the date parts of date time, and duration is the time part. And again, they can be passed in. Say for example, where you might find this useful is say you had some business software, and you had these methods that your office does a stock check every week or something. So you might have you have lots of code in here, and you're using the plus week method, plus weeks one. In several places, because that's every week you do this particular stock check, and you might have in your code plus weeks called 50 times, say. So if it changed and it went to 2 weeks, you'd have to change the code in 50 places. But if you delegated that responsibility to this period class, then you wouldn't have to do that. Of course, you'd be able to just change it once in the period class, and that would be passed into those 50 methods. So you'd only have to make one code change. So so there it is there. So just have to be aware of that period class and the duration class. And rather than doing so here, doing that was the same as doing plus months and adding one to it like that. It's exactly the same thing. We're just doing plus and adding the time period that we call in there. So here's just some more examples of like using that period class. So annually of years, quarterly of months, 3 of them, every 3 weeks, period of weeks 3, every other day, period of days 2, every week, year and a week, period of years 1, day 7. Again, it's showing these overloaded of method there and the various different of methods you can get on that period class. I'll change that. So we've used this various periods just to model those different types of time periods there. Just print those out just to show them there. And you can see that internally that's how these periods are kind of represented. So with the period of years 1 is modelled like that, P1Y, and you can see all these different ones here. Like period of 3 weeks is actually P to represent period, 21D, 21 days. So that's how these kind of get modelled behind the scenes, internally. And you have to be careful to. Well, another thing is we've talked about chaining. So using the period, it doesn't reliably chain. So it doesn't cause a compiler error. But if you try to do that, if you try to say, okay, period of years dot of weeks, you might think that would be 1 week and 1 year, but it doesn't predictably. You shouldn't do that with the period class. It doesn't sort of predictably work. In fact, it's just ended up doing 7 days, so it's kind of like overspilt to the next year, but not included it in there. So it's unpredictable using chaining these together. You should just use one of them really. And obviously, if you do want 1 year in 7 days, we did it there. You can do it there in this of method here. So again, in a similar way that you've got plus as a method on its own, then you've got plus minutes, plus seconds, plus days. You've also got of on its own, where you pass all the different things in, or of days, of weeks, etc. So you've got all these different options of how to do it. As we said, duration is the same as period, but it's simply like for the time period rather than the date period or time. So I'll run that. It's fairly obvious what we're doing there. Duration is the time part rather than the date part. So again, it's modelled like that. And I was saying here, make sure you use the right type of period with the right class. So here again, we're constructing a date time by passing in a date and a time here, which is what we've done like quite a few times in this class. And then we've got this period of 1 month, and we add that period to it. and we can add that period to a date or to a date time, because a period of a month applies to a date and a date time, so they both work absolutely fine. And that's fine to do that. So we're adding a month to them. They start off as 20th of January, so they both become 20th of February. But what we can't do, we can't pass a period of a month to a time. So if we try to actually run that, we get an unsupported temporal type exception. So it's a runtime exception. You're trying to put a month into a time, which is obviously incompatible. The final thing to cover now, it's a few lines of code, but it's just one principle, is formatting. So as you notice, when we'll be printing these examples out, the formatting's, you get the default formatting. It's not great, you know, it's okay. It tells you what you need to know, but you might want to, particularly if you're writing reports or documents, or you want to persist something in a database in a particular format or a flat file, you want to format your dates. So what we've done so far, we haven't bothered about formatting. We've just passed the dates into our debug statements as they are. But there is this, all three of those objects have a format method in which you can pass in a datetime formatter. So they all have this format method. So when I tidy up this class and save it, I'll add this to the Java doc here, the key methods we need to know. But you can call format on it and pass in a date time format. Now this is just one of them, ISO local date, ISO. So this kind of will print the date format that is sort of your typical standard for your time zone. And what you'll find with those is that they'll be basically exactly the same as if you do nothing, because if you do nothing, it'll use that by default. So just print those out. We should get two sort of repetitive looking, yeah. So they look, these three look exactly like those three, because we have passed in a date formatter, but it's the default one for our locale anyway, so it's not going to make any difference. So here's another example of one. There's one called format style short. So if we just, let's see what it looks like if we pass that formatter into the format method of both the date time and so we've got short date time, yeah, and we're formatting, yeah, we're formatting a date, time, and a date. So let's have a look. So that's that is these two here. I wanted to put that's their first of so 20th of January 20. They just come out like that. So it's a very short form of it. Then what we've got here, so the most important one, the one that we really want to use, is our own. What we'll use most of all if we are going to be formatting dates is create our own formatter, our own personal datetime formatter. So this is how you create. So here we're passing in date form. We're actually passing in a date formatter here, but and we're using a standard one. We're using standard ones, but here we can create our own. So give me, I'm saying my personal datetime formatter, I want it to be of that type here. So of pattern, and passing in a pattern, a bit like how we configure our log4j files. And then if I just print that out for a date time, and it prints it out nicely like that. So obviously that would be suitable for a document or whatever. So I passed in a date time there. If I pass that into a date and a time object and try to do the same thing, I get unsupported temporal exception, because for a date and a time, so for this date object, these time elements don't make sense, and for the time object, these date elements don't make sense, so you can't use that formatter there. So the final thing to show you is just creating a formatter also purely for date there, and then purely for time there, and just print that off. And so finally we get our formatted objects there. So that's just the final bit, just formatting dates. So that concludes chapter 3.